in this. You can really, you can see it later. So it's called test. Test of hypothesis. All right. So testing hypothesis is an important part of statistics. So for example, if it's let's start with some examples. Example 1, right? Suppose you want to test the hypothesis. So somebody may have a hypothesis. Say, for example, the average. The average weight of men kg, right? That could be a hypothesis. But for every hypothesis, there's an alternative hypothesis. So, for example, you could test the statement that the average weight of man equal to 80 kilograms versus an alternative statement that all right. So this is one example. So you're trying to test the hypothesis whether the average weight of man is equal to 80 kilograms versus the alternative hypothesis that is not equal to 80 kilograms. So other example, so that's example 1. Another example 2, could be like this. You could test the hypothesis that the average weight of man is equal to 80 kg versus the alternative that the average weight of man is less than 80 kg, right? So this is example 2, right? So sorry, this is 2. Sorry, can you? This example number 2. Okay. And another example number 3 would be something like this, where we have average right is equal to 80 kg versus the alternative. Remember, for every hypothesis, there's an alternative hypothesis. So that's what I'm trying to say here in these 3 examples. So in this case, the alternative hypothesis could be the average these are three examples where you have two statements. One is a statement that you're trying to test, right? And then you have a statement which is an alternative statement. That's usually known as the research statement or research hypothesis. So okay. So I'm gonna, okay, these are two examples. Let me use my handwriting. I mean, my handwriting is getting poorer every day, but I'm trying. It's not easy to write on a iPad, as you know.
Oh.
I guess, okay. There are various elements of test of hypothesis. The first one is known as the null hypothesis. Okay. And it's denoted by H0. Okay. Capital H subscript, capital H subscript. And the hypothesis sorry, somebody tried to Skype me, sorry. This is the hypothesis to be tested, right? So I'm going to talk about the various elements of testing hypothesis. The first one is the null hypothesis, and the second one is the alternative hypothesis. So is denoted by capital H. Is denoted by capital H subscript 1, and this is it's known as the research hypothesis. So this is known as the research hypothesis. So in the examples that we looked at earlier, so it could be like the average weight less than 80 kg or greater than 80 kg or not equal to 80 kg. And all right, so those are the first two elements. The third element is it's known as the test. And it's denoted by the letter capital T, and it's a function of the data x1 to xn. So this is so as I said, it's a function of the data. right? So it's a function of the data that is used to determine whether the null hypothesis or the alternative hypothesis is true, right? So T is, as I said, it's a function of the data, right? Okay, number four is the rejection rule. Or maybe I should write it like this, sorry, excuse me. So it's number four is it's known as the rejection rule. It's the rule for rejecting the null hypothesis, and it usually takes one of the following forms. So it either it takes the following form where the test statistic T is greater than a constant, right? Where K is a constant, or it takes the form where the test statistic is less than a constant. So this is n, guys. Sorry for my writing. Okay. So this is known as the rule for rejecting the null hypothesis, right? That's number four. Number five is the following: is the rejection region. The rejection region is defined as follows: is equal to set of all data belonging to the sample space. S. You may remember from early on in the course that capital S is the notation I have used to denote the sample space, right? So it's such that so this is the rejection region, right? And so that's number five, and finally number six. Number six is the opposite of rejection region, which is acceptance region. So it's acceptance. It's defined as a set of all data points belonging to the sample space S, right, such that the rejection region does not hold. So rejection rule, rather. Rejection rule all right, guys. So that's those. So these are the six elements. So these are elements of a you see this, guys, of test hypothesis, right? And the next thing I want to talk about is often, okay, you have any questions so far, guys? If you have questions, just you can use your microphone, or you can use the chat box to type your question. I'll be happy to answer any questions you have. All right. Okay. Now, there are certain problems with testing of hypothesis. Now, what I'm going to talk about now is two of the problems you have when you testing hypothesis. Right. All right. So let me draw a box. All right. I'm going to draw a box. Give me a few minutes. So excuse me. My writing is getting very bad these days. Sorry. Come on. Okay. There are two things you need to consider. The first is the state of nature, which we have no control over, and the second thing is the human decision, the decisions made by people like us. All right. And there are two possible outcomes. State of nature can be one of two things. All right. Either H0 is or H0 is false. Right? And let me write this in let me write it. So the human decision can be the human decision can also take two different outcomes, right? The two different outcomes are either you reject the null hypothesis, all right, or you accept the null hypothesis, right? So you see, there are these are these are the two possible outcomes of the decision made by people like us. All right, and the state of nature can also have two possible outcomes whether H0 is true or H0 is false. So basically you have four possible outcomes, right? You have four possible outcomes. Do you see what I'm trying to say? There are four possible outcomes. Now, now let me go through each of these four outcomes. If H0 is true, and you're rejecting H0, then you're doing the wrong thing. So this is a mistake, right? If H0 is true and you're accepting the null hypothesis, then what you're doing is correct. If H0 is false and you're rejecting the null hypothesis, then what you're doing is correct. If H0 is false and you're accepting it, what you're doing is not correct. So that's four outcomes. There are four outcomes, and two of the outcomes are not correct things to do, and two of the outcomes are the correct things to do. Do you follow me? Right? And this outcome where H0 is true and you're rejecting H0 is known as This outcome is known as the type 1 error. All right? And this outcome where H0 is false and you are accepting the null hypothesis is known as the type 2 error. You follow me? Yeah. So type 1 error is the event that you are rejecting the null hypothesis when in fact it is true. And type 2 error is the event that you are accepting the null hypothesis when H0 is false, right? So let me write it down. So let me, so type 1 right? Okay, type 1 error is the event of rejecting H0 when it is true, right? And type 2 error is the event of accepting H0 when it is false, right? Okay, so these two errors are bound to happen in any test of hypothesis. It doesn't matter. I mean, you can be the most brilliant statistician in the world, but these two errors will always happen. So there's no test of hypothesis in the world where type 1 error and type 2 error will not happen. Okay. So, but what we can try to do is we can only try to minimize the chance of type 1 error and the chance of type 2 error happening. So to do that, okay, I need to first define a few things, right? So let alpha denotes the probability of type 1 error. Okay, so it's the probability of so in other words, it's the probability of rejecting H0 is the probability of rejecting H0 when H0 is true. Okay, it's a conditional probability, as you know. Okay, and let beta denote the probability of type 2 error. Okay, so in other words, it's the probability of accepting H0 when given that H1 is true. Okay, so what we should try, I mean, in practice, we try to in practice we try to minimize oh sorry, what am I doing? Okay, here we are. We try to minimize the values of alpha and beta. Okay. All right, guys. So as I said before, it's impossible to eliminate, it is impossible to have alpha equal to 0 and beta equal to 0, right? Because, yeah, I mean, we are only human beings. We are always bound to make errors. So we are always, I mean, you can be the most intelligent person, but still you can make errors. So what we can try to do is only try to minimize alpha and beta. All right. Okay, guys. All right. Next, one other notation I need to. One other notation. The alpha is also known as is also known as the significance level of a test. So let me write this down. Significance level. Significance level. Okay. It's also known as the significant level of the test of. Okay. Right. So that's another name for the alpha, the probability of type 1 error. All right. The next thing I'm going to do is I'm going to state some test. I mean, for this course, you don't need to know how to derive the test. You only need to know how to apply the tests, right? It's not like in confidence interval. I mean, when I talked about confidence interval, I showed you some derivations, how to derive some of the tests, some of the confidence intervals. But here, in testing hypothesis, I don't expect you to know how to derive. But when you go into your year 2, I mean, year 2, you will take a course called statistical methods, and in that course, you will learn how to derive tests, right? I mean, so let me start by showing you how to do some test, right? So I'm going to start with the one sample test. So this topic is on one sample. Maybe I should put, okay, excuse me. One sample test. Okay. The first thing is the first thing I'm going to do is the following. A test for population mean. Right, I'm trying to test for population mean. I will explain in a minute what I mean by this. When population variance is known, right? So I'm going to assume the following. So I'm going to assume that you have a data set x1 to xn, IID from a normal distribution with parameter mu and variance sigma squared. So I'm going to assume that sigma squared, which is the population variance, is known, right? So the question is how to do the testing. How to do the testing for mu. Mu is the population. Remember, mu is the population mean. Sigma squared is the population variance, right? So I will show you now how to do the testing. All right. So again, there are three kinds of tests available. The first one, all right, where the population mean is equal to some constant mu zero, right? Mu zero is a prescribed, pre-specified constant, versus the alternative that mu, the population mean, is not equal to that constant, right? So for example, mu could be the average weight of men, and mu zero could be 80 kg, right? So this goes back to the example that we did earlier, all right? And then you can have a test where the null hypothesis is this, right? Versus the alternative that mu is greater than mu zero. So here the alternative says that the population mean is greater than a constant. So for example, it could be that the average weight is greater than 80 kg, for example, right? And the third example, the third case is this one, is where mu is equal to mu zero versus the alternative that mu is less than mu zero, right? So once again, the mu zeros here are constant. So in the three examples I did at the beginning, mu zero could be 80 kg, for example, right? So for each of these tests, each of these hypotheses, there's a rule for rejecting. So for this one, for the first one, you reject H0, right? If root of n is the sample size, divided by sigma. Sigma is this population standard deviation, multiplied by x bar. X bar is the sample mean, minus mu zero, which is the pre-specified constant, is greater than z 1 minus alpha by 2. I'm sure you know how to read this. So this is the rule. This is the rule for rejecting the null hypothesis for the first one. For the second one, the rule is slightly different. It's root of n divided by sigma multiplied by x bar minus mu zero, all right, greater than z or z 1 minus alpha. Okay. And for the third set of hypothesis, this is root of n divided by sigma x bar minus mu zero less than minus z 1 minus alpha. Okay. So these are the three rejection rules corresponding to the three sets of hypotheses. Once again, I'm not going to tell you how to prove this, but as I said a minute ago, you will learn about how to prove this when you move to your second year, right? So these are the rules for rejecting. Yeah, I mean for this year, for year one, you only need to know how to apply these rules, right? Not how to, just to apply the rules. Okay. You have any questions so far, guys, or no? Hello, guys. Are you guys still there or no? Yeah. I mean, hello, guys. Are you there? Any question, just feel free to ask me, okay? Okay, right. So this is testing for the population mean when the population variance is known. And the next thing I'm gonna do is, oh yeah, Daniel, you have a question, Daniel. Sorry, I can't, all right, let me. The sound isn't very clear, James Weston. The first one is the normal brackets or integer part. Okay. All right. Let me answer that question. Just a minute. Can you all hear me? By the way. Somebody said the sound is not clear. Can you all hear me or not? This this is the absolute value, guys, not the integer part. Okay. This is the absolute value. Okay. I know Daniel asked me this question, but this is, so for the rejection rule for the first set of hypotheses is root of n divided by sigma times the absolute value of x bar minus mu 0, which is denoted by capital vertical bars for absolute value. Okay, thank you. All right, thank you, guys. All right, let's move on. The next one is all right, so this is, okay, thank you, Daniel, for asking that question. All right, next one, so that's part A. Part B is, I'm gonna talk about test for population mean when population variance is unknown. Okay, so in this case you have the similar setup as above, but just the rules are different. So here you assume that, okay, suppose right? So you assume you have a random sample from a normal, where the population variance sigma squared is unknown, right? So you have the, so let me write down the rejection rules one more time. Okay, before I do that, I need to rewrite the three sets of hypotheses. So okay, and Okay, these are the three sets of hypotheses. And the corresponding rejection rule are as follows. So the first one, you reject H0 if the following is true. Root of n divided by s. Remember, s is the sample standard deviation. If you look back in the notes, you will see the definition, but I will write it again in a minute. So let me give you. So once again, these are absolute values of, okay, not integer part. So this. So here you need to read the t table, and I showed you how to do that in the class a long time ago. I mean, and here is root of n divided by s times x bar minus mu 0 greater than t n minus 1 alpha. Okay, and for the third one, root of n divided by s x bar minus mu 0 less than minus t n minus 1 alpha. All right, so these are the three different rules for the three different hypotheses, right? So let me once again put the rules in red. So these are the rejection rules, right, corresponding to each of these three hypotheses. Okay, and each of them involve the S. S is the, I will write down one more time. You might have forgotten. So where S is the sample standard deviation and is defined as the square root of n minus 1, not n. Okay, the unbiased, I'm using the unbiased version, not the biased version. Okay, so this is, okay, so this is the S, and it's known as the sample, it's known as the sample standard deviation, or SD. Okay, sample standard deviation. Okay, so that's B, and next one is all right, that's, so what I've done is A and B so far. Now let me go to C. Come on guys, just a minute, give me a sec. Right, now part C is testing for test for population standard deviation. All right, so here we suppose the data comes from, so we suppose once again that the data comes from a normal distribution. Right, where mu is unknown. And here we want to test for sigma, right? Remember, sigma squared represents the population variance. So sigma represents the population standard deviation, right? Okay, so we want to test for sigma, right? So once again, there are three sets of hypotheses available. So the first one is sigma equal to sigma 0, where sigma 0 is, once again, is a pre-specified constant. Okay, so that's one set of hypotheses. The next one is it's H0 versus, excuse me, H1, where sigma is greater than sigma 0, and the third one is H0 versus sigma equal to sigma 0 versus sigma less than sigma 0, right? So you have three sets of hypotheses, and the corresponding rejection rules are as follows. So for the first one, you reject the null hypothesis if one of the following is true, right? So the first one, n minus 1 s squared. S squared is the sample variance divided by sigma 0 squared is greater than chi-squared n minus 1. So these are percentiles of the chi-square distribution, and I'm sure you know how to read it. I talked about it a long time ago, you may recall. Or, right, the same thing, which is n minus 1 s squared divided by sigma squared, right, divided by sigma squared is, excuse me, sorry. My writing is getting worse every day, sorry. Is less than chi squared n minus 1 alpha by 2, right? So if one of the following, if one of these two inequalities is satisfied, then you reject the null hypothesis. That's for the first one. For the second one, you reject H0 if okay, and for the third one, you reject H0 if you can guess what it will be, chi squared n minus 1. Sorry, this should be, I made a mistake already. This should be 1 minus alpha, not alpha. So this should be 1 minus alpha. This is chi squared n minus 1 alpha. Okay. Okay, guys. So these are the rejection rules are as follows. For the first one, this is the rejection rule for the first hypothesis, right? Okay, for the second hypothesis is this one, and for the third hypothesis is this one. Okay. So once again, I mean, I'm not. If you want to know how to derive this, you will have to wait another year. So don't be impatient. Okay. So just. Excuse me, sorry. This should be n minus 1. Did I write wrong? This is n minus 1 here. Okay. So this is part C, where we were testing for population variance. Now, the last case is part D. In part D, I'm going to talk about how to test for population proportion, right? And after that, I will I will finish for today. So let me give you, please let me give you, let me give some time, guys, to do part B. Okay. Okay, so this will be the final part for today, and then when you guys come back after Easter, I will do 2 sample tests. All right. So this is testing for population proportion. So in this case, we are supposing that the data, we are supposing that the data are IID from a Bernoulli distribution, with parameter P. And remember, P represents